Hey everyone, today I want to introduce you to Richard Feynman, one of the most brilliant physicists of the 20th century. He made groundbreaking contributions to quantum mechanics, especially in the field of quantum electrodynamics. But Feynman wasn't just a scientific genius. He was also a mesmerizing teacher, a master storyteller with a sharp sense of humor, and a creative thinker who approached problems in unexpected ways. His life was a never-ending journey of discovery, and his legacy continues to shape the worlds of science and education. Youth and education. Richard Feynman was born into a Jewish-American family, and from an early age he displayed exceptional intelligence, especially in mathematics and logical thinking. His father, a man with a deep passion for science, but without the opportunity to pursue an academic career, instilled in him a spirit of curiosity and critical thinking. Instead of simply accepting things as they were, Feynman was taught to question everything and observe the world with a scientific mindset. As a child, he loved figuring things out on his own, often dismantling household electronics just to understand how they worked. By the time he was in high school, he was already teaching himself advanced mathematics, including calculus, something most students didn't encounter at that age. He even invented his own mathematical notation to help him solve problems faster and more efficiently. Throughout his college years, Feynman stood out for his ability to tackle complex problems in a highly creative and intuitive way. He wasn't just brilliant at finding solutions, he also had a rare talent for explaining ideas with clarity and simplicity. His sharp mind and unique approach to research quickly earned him recognition in the scientific community, setting him on the path to becoming one of the greatest physicists of the 20th century. Scientific contributions. Richard Feynman was one of the most influential theoretical physicists of the 20th century, making groundbreaking contributions across multiple fields. Among his most significant achievements was his work on quantum electrodynamics, QED, which provided a detailed explanation of how light and charged particles interact. Quantum electrodynamics and Feynman diagrams. Before Feynman's contributions, quantum electrodynamics was plagued by complex equations that led to infinite, unmanageable results. Feynman revolutionized the field by introducing a new approach that was not only mathematically precise, but also highly intuitive. His most famous innovation was the Feynman diagram, a visual tool that depicts the interactions between elementary particles. These diagrams made it much easier for physicists to visualize and calculate quantum processes, such as the emission and absorption of photons by electrons. Today, Feynman diagrams are an essential part of modern physics, simplifying calculations in quantum field theory and remaining widely used in particle physics research. For this groundbreaking work, Feynman was awarded the 1965 Nobel Prize in Physics, along with Julian Schwinger and Shinichiro Tominaga, who also made significant contributions to QED. Contributions to quantum mechanics. Feynman made major advancements in quantum mechanics. He developed the path integral formulation, a novel approach to understanding the behavior of microscopic particles. This theory suggests that a particle does not follow a single path, but rather explores all possible paths simultaneously, with the final outcome being a sum of all these possibilities. This formulation not only deepened our understanding of quantum mechanics, but also became a crucial tool in fields such as statistical physics and string theory. Research on superfluidity. Feynman also made remarkable contributions to condensed matter physics, particularly in the study of superfluidity. When helium atoms are cooled to extremely low temperatures, they can enter a superfluid state, flowing without friction. Using the concept of quantized vortices, Feynman explained that superfluidity follows strict quantum rules, meaning the fluid cannot move in just any way, but must obey specific quantum constraints. His research had a lasting impact on solid-state physics and continues to influence scientific exploration today. Foundation of quantum computing. Feynman was also one of the pioneers of quantum computing. He recognized that classical computers struggle to simulate complex quantum systems and proposed that a computer based on quantum principles could perform these calculations much more efficiently. This idea laid the foundation for the development of quantum computers, an emerging field that is now receiving significant investment and has the potential to revolutionize information technology. Role in the Manhattan Project. During World War II, Feynman was part of the Manhattan Project, the top-secret U.S. research initiative that developed the atomic bomb. He worked at Los Alamos alongside some of the world's greatest scientists, including J. Robert Oppenheimer. Feynman played a key role in calculating nuclear fission reactions and designing the bomb. However, after the war, he grew increasingly skeptical about nuclear weapons and deeply reflected on their impact on humanity. Other discoveries and ideas. Beyond these fields, Feynman made contributions to astrophysics, statistical field theory, and many other areas of physics. His creative approach to science often led him to solve problems in unconventional ways that others had not considered. Feynman's contributions not only transformed our understanding of the universe, but also laid the groundwork for numerous modern research fields. His innovative thinking and unique problem-solving methods continue to inspire generations of scientists. Influence and teaching style. Richard Feynman was not only a brilliant scientist, but also an extraordinary educator and an inspiring communicator. He had a rare ability to break down complex concepts into simple, engaging explanations, making profound scientific ideas accessible to both students and the general public. His teaching philosophy profoundly influenced modern physics education and continues to inspire generations. Teaching philosophy: simplifying complexity. One of Feynman's most defining qualities as a teacher was his ability to simplify scientific concepts without sacrificing accuracy. He believed that if you couldn't explain something in simple terms, you didn't truly understand it. Instead of relying solely on complex equations, he used real-life analogies and intuitive reasoning to help students grasp difficult subjects. This approach made him one of the most beloved lecturers at prestigious institutions like Caltech, California Institute of Technology. One of his most famous learning techniques, now known as the Feynman technique, provides a simple yet effective way to master any subject. It consists of 4 key steps. 1. Learn a concept and understand it deeply. 2. Explain it in simple terms, as if teaching a child. 3. Identify gaps in your understanding and revisit the material. 4. Refine and simplify your explanation until it becomes clear and coherent. This method has become a widely adopted learning strategy, not just in physics, but across various disciplines. The Feynman Lectures on Physics. One of Feynman's greatest educational legacies is the Feynman Lectures on Physics, a 3-volume series based on his lectures at Caltech. These books cover topics ranging from fundamental principles to advanced theories, serving as an invaluable resource for students and scientists worldwide. What makes these lectures special is not just their scientific depth, but the way they are presented. Feynman didn't merely list formulas and theorems. He told stories, posed thought-provoking questions, and encouraged readers to discover answers for themselves. His lively and engaging teaching style shines through every page, making learning an exciting journey rather than a chore. Even today, this series remains a classic in physics education, inspiring countless students and professionals. A creative approach to problem-solving. Feynman's unique approach to problem-solving set him apart from his peers. He never blindly accepted existing theories. Instead, he constantly questioned, tested, and sought alternative solutions. Rather than following conventional methods, he often devised completely new ways to tackle problems. This creativity was evident in his research, where he introduced novel approaches that others had overlooked. For example, in solid-state physics, instead of using traditional differential equations, he visualized problems as animated diagrams, allowing him to solve them in a more intuitive and insightful way. Curiosity, humor, and a playful mind. Feynman wasn't just a serious scientist. He was a man full of humor, passion, and an insatiable curiosity about the world. His interests extended far beyond physics, including art, music, and even safe-cracking. While working on the Manhattan Project, he amused himself by figuring out how to open safes containing classified nuclear secrets, not out of malice, but simply to challenge himself and understand security flaws. He also had a deep love for music, particularly the bongo drums, which he taught himself to play. He often performed at parties and even joined local musical groups, showcasing his vibrant personality. Inspiring future generations. Feynman's impact extended beyond the classroom and research lab. He inspired countless individuals through his books, public talks, and personal stories. One of his most popular books, Surely You're Joking, Mr. Feynman, is a collection of humorous and insightful anecdotes from his life, offering a glimpse into his adventurous and unconventional way of thinking. He believed that science should not be dry or intimidating, but rather an exciting, exploratory adventure. He emphasized that true understanding comes not from memorizing formulas, but from thinking critically and asking the right questions. A lasting legacy. Feynman revolutionized both science and education. His innovative teaching methods made physics more engaging and accessible, while his groundbreaking research laid the foundation for modern advancements. Though he is no longer with us, his spirit of curiosity, creativity, and relentless questioning lives on, inspiring anyone who seeks to uncover the mysteries of the universe. Legacy and influence. Richard Feynman was not only an outstanding physicist, but also a cultural icon in the scientific world, with an influence that extended far beyond his specialized field. His contributions shaped theoretical physics, transformed education, and redefined creative thinking. His work remains highly relevant today, and his intellectual legacy continues to inspire scientists, engineers, educators, and curious minds across generations. Scientific legacy. Feynman left a profound impact on many areas of physics. One of his most significant contributions was in quantum electrodynamics, QED, which played a crucial role in shaping modern particle physics. Today, physicists still use Feynman diagrams to calculate particle interactions, making quantum field theory more accessible and practical. Additionally, his path integral formulation remains a foundational concept in quantum mechanics and field theory. It provides a deeper understanding of microscopic particle behavior and finds applications in various domains, including particle physics, astrophysics, condensed matter physics, finance, and artificial intelligence. Feynman's research on superfluidity, particularly how quantum vortices form in ultra-cold helium, continues to influence condensed matter physics. These discoveries hold theoretical significance and practical applications in cooling technologies and superconductivity research. Beyond physics, he was also a pioneer in quantum computing. His idea of using quantum systems to simulate other quantum systems laid the groundwork for quantum computing, a field that is rapidly evolving and may revolutionize information technology in the future. Influence on education and learning philosophy. Feynman had a deep passion for education. He didn't just teach physics, he taught how to think critically and approach problems scientifically. His teaching methods have influenced generations of students and educators, reshaping the way physics is taught worldwide. His book series, The Feynman Lectures on Physics, is still regarded as one of the best physics textbooks ever written. Unlike traditional dry textbooks, this series presents physics concepts through engaging stories and intuitive explanations, rather than just formulas. He also developed the Feynman technique, a widely used learning method based on simplifying and re-explaining knowledge in an easy-to-understand manner. Today, this technique is applied not only in physics, but also in business, technology, and education. Role in society and applied science. After working on the Manhattan Project, Feynman became more aware of the real-world implications of scientific advancements. He understood that nuclear weapons brought both potential and peril, emphasizing the ethical responsibility of scientists. One of the most famous moments of his later career was his role in investigating the Challenger space shuttle disaster in 1986. When the Challenger exploded shortly after launch, NASA formed a commission to investigate the cause, and Feynman was invited to join. Instead of relying solely on reports and official statements, Feynman conducted direct experiments. He discovered that the rubber O-rings in the rocket engine became brittle at low temperatures, leading to the failure that caused the explosion. In a now iconic moment, he demonstrated his findings on live television by dipping a piece of rubber into a glass of ice water, showing how it lost its elasticity in cold conditions. His discovery forced NASA to reassess its safety protocols, leading to improvements in future space missions. Influence on popular culture. Feynman was not only renowned in scientific circles, but also became a cultural icon, thanks to his charismatic personality, humor, and unrelenting curiosity. He wasn't just a scientist, he had a deep passion for various fields, including art, music, and even code breaking. He taught himself to play the bongo drums and regularly performed at events. He also traveled to Brazil, where he not only lectured, but also learned to play samba music. His adventurous and playful approach to life made him one of the most beloved scientists in history. Feynman also left a mark through his books, particularly Surely You're Joking, Mr. Feynman, a collection of humorous and fascinating stories from his life. This book not only provides insight into his personality, but also inspires readers to embrace curiosity and creativity in their own lives. Impact on future generations. Even after his passing, Feynman's influence continues to grow. His lectures, books, and philosophies are still studied, quoted, and applied in various fields. Today, many physicists, educators, and computer scientists continue to learn from Feynman's methods. His ideas on quantum computing have become increasingly important, and his work in quantum mechanics remains foundational for modern research. His critical thinking, creativity, and relentless curiosity have become a model for scientists and science enthusiasts worldwide. His teaching materials are still widely used in education, and many continue to adopt his learning and problem-solving approaches in various disciplines. Conclusion. Richard Feynman was not only a brilliant physicist, but also an inspiring figure whose impact transcended generations. He helped shape modern physics while revolutionizing the way people approach knowledge. With his unique teaching style, creative mindset, and boundless curiosity, he left behind a monumental legacy, not only in science, but also in how we think and learn. Though he is no longer with us, his spirit lives on in the scientific community and in those who seek to understand the world. As he once said, "I have no idea what the future holds, but I do know that those who wish to understand the world will continue to explore and discover. That is the essence of science."